So what we're going to do is we're going to work with logarithms, and logarithms are just another way of writing exponents. So what we want to do is be able to convert back and forth. So the first thing we're going to do is take a logarithm and understand the parts of the logarithm. This, the small number down here by the log is called the base. The number it equals, so logs equal exponents, is the exponent. And the answer to that exponent is what the log is. So what we have is we want to convert this. So if 2's are base, 3's are exponent, then it equals whatever the log is, and it's the log 8. So that's 8, which is true. 2 to the third power is 8. And that's how we convert from a logarithm into an exponent form. So let's look at our next problem here. Our base is 4, so it's log base 4. But I have a -4 is my exponent, which makes sense because our answer equals a fraction. And the reason why it makes sense is because, remember, a negative means to flip. So this is really 4 to the 4th power flipped over, which is where we get 256. So here's our two answers when we're converting them to exponents. Now let's look at going the other way around. What if we have an exponent? How could we convert to a logarithm form? Well, remember, we're gonna write log, and it's going to be a log with the base. Well, the base is 15, so there's my little 15 that I write down here. And the exponent is what it's going to equal. So it's going to equal 3. And so our answer is always our log. And so we've just converted it into logarithm form. So let's do another one. Our base is 4, so I'm going to go log 4, because that's where the base is. Our exponent is our answer, so there's 1/2. And so we're gonna have 2. So it's a log base 4 of 2 equals 1/2. Evaluating logarithms is a little more difficult because we have to change our base sometimes. So let's first write this problem. Base 16, and we don't know our exponent, but we want it equal to 4. So I just converted it into exponent form. So what I'm trying to do is I got to get these two numbers to be the same. Well, if you think about it, 16 is the same thing as 4 squared. So I'm going to rewrite 16, 4 squared. We still have our x, and we have 4 over here. And it's an exponent of 1 because anything not written is 1. So if we have the same base, which we do now, we can take the exponents and make them equal to each other. So 2x equals 1. And now we can solve for x by dividing by 2 to get x equals 1/2. And so we evaluated log of base 4, or base 16 is 1/2. Which would make sense if we were to do a quick check. If I go 16 to the 1/2 power equals 4 and type this into your calculator, you will get 4. All right, so let's look at the next type of solving. So the same thing holds true. We want to always have our base be the same. So if we make this 3, we don't know what our answer is. I'm going to make that an x, but we equals 81. So I just changed to exponential form. There's our base. We don't know what our exponent is, and it equals 81. We have to get these two base to be the same. So always take the bigger one and try to make it into the smaller. So technically this is 9 times 9. Well, 9 is 3 squared. So we basically have, this is 9 squared, but that's not the same. So what I need to do is change it to a 3, but 9 is really 3 squared. We still have the 2. So I'm just changing the 81 to 9 squared and then the 9 into 3. Now I have the same basis. So I can then make, and this is a 2, I can now make my exponents equal to each other. So x equals 4, because 2 times 2 is 4. And so we have our answer for this equation. So this equals 4, which once again, if we do a quick check, 3 to the 4th power, what does that equal? Well, if you do that in your calculator, it will equal 81. So it checks out. So to solve these, we're looking at trying to have the same base. And sometimes you have to take a base that, if you can go right from 81 down to the 3 to the 4th power, because you know 3 times 3 times 3 times 3 is 81, then you don't have to go to this next step. But I know 9 times 9 is 81, and that's how I went down to that part.